Hello and welcome back to Nunley Math. I am your host, Aaron Nunley. I appreciate you joining us here today as we begin our discussion of functions. This will be our fourth unit in Algebra 1. We began with a discussion of expressions and equations. We then spent some time talking about application problems, and then we took that information and used it to examine inequalities. Now, functions is kind of a different turn for us. It's going to cause us to look at numbers in a slightly different way, and it's going to begin to cause us to think about how numbers are connected to one another. Now, this video could get just a little bit long, so I am considering splitting this into two separate videos. If so, make sure that you check out both Part A and Part B in order to get the entire lesson. The information we talk about here is very foundational to some bigger and broader ideas that we discuss with functions. The goal of this entire unit is to give you an idea of how of what a function is, how functions relate to one another, how changes in functions affect the graphs of functions, and to help you become familiar with the most common types of functions that you're likely to encounter both in Algebra 1 and also a little bit in Algebra 2. So, without further ado, let's go ahead and get started. I do want to talk to you about a few definitions or terms just right from the outset. I know it is kind of tedious to do definitions, but I think the better we understand these things, the easier the rest of this information is going to be to deal with. So, by the way, you'll notice that in my class, as we're beginning to do this discussion, we are in October, approaching Halloween, so we've got a little bit of a Halloween theme going on here. I hope you enjoy that. A relation is an ordered pair, or I'm going to underline this word, coordinate, that states the relationship between two sets of information. The first object being called the domain. Please circle that word, domain. Make sure you write that down. And the second object being called the range. Now, you've got several terms here. You've got this word relation, and you've got this term domain and this term range. This term domain and this term range are going to be ongoing terms throughout the entire unit. We're going to use them over and over and over again. So it's extremely important here at the beginning that we understand what those mean. When we talk about a relation, we're saying that two things have a relationship or they are connected to one another. So we're looking for ways to connect a domain to a range. And so I thought I'd start off with something not necessarily mathematical, but that hopefully will help us understand or illustrate this idea of a relation. So let me give you an example. Let's say that I have the coordinate Frankenstein neck bolts. Frankenstein neck bolts. I have another coordinate Dracula fangs, another coordinate mummy bandages, and another coordinate Wolfman claws. Now, you've typically seen coordinates listed in math as just numerical coordinates, like the coordinate, let's see if this is going to work, like the coordinate 2, there we go, comma 3, that you would graph on a coordinate plane. A coordinate is any two things that are connected in parentheses like that. So we can put anything we want in there. Now, obviously, it would be difficult to graph Frankenstein neck bolts, but for our purposes today, I think it's going to work just fine. When we talk about a relation, we're saying that this first item has some kind of a relationship to this second item. And the first item belongs in our domain. So if I were to ask you the domain of this relationship, what I'm saying is, what are all the first items that are given to us? Well, when I look at my list, Frankenstein, of course, is a first item. Dracula is a first item. The mummy is a first item. And the Wolfman is a first item. And so I collect those and put them in braces. and I would just call them collectively the domain. That's the whole set of first values. Notice, by the way, I am using braces. We do that on purpose because we don't want to confuse those with parentheses if we happen to put parentheses inside of this domain. Some people tell me these are really hard to draw. I find it's easiest to draw this first one as an S with a 2 under it. Wow, that's really bad. It's hard to do with a mouse. And the second one I tend to do as a 2 with an S under it. And you'll find with practice you can make your braces pretty easily that way. Let's talk about the range. The range is the list of second objects. The list of second objects, which we're going to do pretty much the same way we did the first objects. We're going to look down here and say, oh, well, it's neck bolts, fangs, bandages, and claws. Neck bolts, fangs, bandages, and claws. The domain is just this first group of values. The range is this second group of values. And we just list those separated by commas and inside of braces. Now, if I were to ask you what relationship seems to exist here, hopefully you can recognize that you're looking at a character or creature and whatever their characteristic happens to be. The domain being who the character is, the range being what that character's characteristics might be. Not too bad, right? Take a look here. Let's say I were to give you the coordinates black cat, green witch, purple people eater, white ghost, and gray wolf. It's just a list of 5 coordinates. Could you write down the domain and range for that relationship? I'd suggest pausing the video, doing that, and then restarting the video so you can see if you're actually understanding what's going on here. I'm going to go ahead and go on. The domain here is black, green, purple, white, and gray. And of course I close that with my braces. Notice that is the first item in every set of parentheses. First item in every set of parentheses or in every coordinate. The range then would be the second item. The cat, the witch, the people eater, the ghost, and the wolf. That's your domain and that's your range. How would you describe that relationship? Well, to me, I see a color matched with a creature. A color matched with a creature. Here's another one. Chocolate bar, pumpkin pie, gummy bears, and Laffy Taffy. Take just a second, see if you can write the domain and range for that set of information, then restart the video. I'm going to go ahead and go on. Your domain here is chocolate, pumpkin, gummy, Laffy. Your range, on the other hand, is bar, pie, bears, and taffy. Not too bad, right? If I ask you to describe this relationship, you might say something like flavor and food. The domain or first item being the flavor, the last item being the food. Now, I think if we get into taffy and bear, you could probably get a little questionable about food. You may not call Laffy a flavor, but I think for our purposes here today, it illustrates this pretty well. Now, here's what I want to do. I want to take this idea of domain and range, and I want to apply it to numbers. We're going to make this a little more mathy this time. Consider this. 3 matches to 7, 4 matches to 9, 5 matches to 11, 6 matches to 13, and 7 matches to 15. Just like our relationship before, we should be able to look at these and find a domain and range. Can you do that? I'm going to assume you paused the video and did that. The domain here is 3, 4, 5, 6, and 7. Your range then would just be the 7, the 9, the 11, the 13, and the 15. It's the exact same thing we did before, except now we're just working with numbers. I like to start with things besides numbers because I think when you create that story, it helps you to separate it in your mind. So when you see the numbers, it's not really as off-putting or challenging. The relationship here is a little more difficult to describe. Once we get farther into the unit, we can come up with a pretty good explanation. So for now, I'm just going to call my coordinates x and y. Notice that the domain is all those values in the x position. The range is all those values in the y position. Here's your domain, x. Here's your range, y. Here's one more, just to make sure we've got a good handle on this. Can you give me the domain? How about 0, 3, 12, 21, and 2? What about the range? 10, 17, 30, 52, and 5. Not too bad, right? Relations are fairly common, and if you understand what the definition of domain and range are, they really aren't that difficult to work with. Let's talk for a minute about what a function is. A function is a mathematical rule that assigns every, underline or circle that word every if you have a paper copy of this, every member of a domain to exactly one member of the range. I'm going to circle that word exactly one. Every member of the domain gets connected to exactly one member of the range. A function is a special or specific type of relation. A special or specific type of relation. It's a special relation. This is hard to do with a mouse. A special relation, because not only is it two things connected, but they're connected in a very specific way. Every item or member of the domain, remember that's the first value or the input value, has to match to exactly one member of the range. So when I look at my initial example from the very first slide, this relation that we talked about where Frankenstein was connected to neck bolts, Dracula to fangs, mummy to bandages, wolfman to claws, it's important for us to notice that Frankenstein only gets neck bolts. He does not also get fangs, bandages, or claws. Dracula has fangs, but he does not get bandages, neck bolts, or claws. The mummy gets bandages, but nothing else. And the wolfman gets claws, but nothing else. Each of these creatures or characters receives or matches to exactly one character trait. That's what makes this into a function. You see, a relation is, in this case, this relation is a function because they each get one attribute. Now, every function is a specific type of relation, but only relations that meet this very specific criteria are considered to be functions. Okay? Now, if Frankenstein got neck bolts and fangs, we wouldn't be dealing with a function anymore. Do you know what we'd be dealing with? We call that Deadpool. Okay, that's a comic book joke. Hopefully you got that. If not, well, read a comic book. I don't know. Hopefully that makes sense to you. I enjoy it. Let's take a look here. I've got a new relationship for you. Ninja matches to Turtle. Princess matches to Anna and Elsa. Darth matches to Vader, and Ant matches to Man. Would we consider this relationship to be a function? No. In a function, Ninja could only match to Turtle, Darth could only match to Vader, Ant could only match to Man, and Princess could only match to one person. But notice in this case, Princess is matched or mapped to two different people. That defies the rule of a function. To be a function, it has to match only to one. We would say this is not a function. How about this one? Is that a function? It is not. Candy corn breaks the rules. Candy corn tries to map to two different relationships or two different values in the range. The rule is every item in the domain can only map to exactly one item in the range. Here's one for you. This one actually is a function because every item in the domain matches to exactly one item in the range. Halloween goes to costume, Christmas goes to Santa, Hanukkah goes to dreidel, and Veterans Day goes to flag. How about that? This one tends to be a little more difficult for people. This one actually is a function. The rule is every item in the domain must go to one item in the range. Cowboy only goes to brains. Mummy only goes to brains. Pirate captain only goes to brains. Pharaoh only goes to brains. Pirate only goes to brains. There's nothing in the definition of a function that says they can't all go to the same thing, just that each of them has to match to exactly one item in the range. By the way, if you've never played Plants vs. Zombie 2, absolutely terrific game for your iOS device. Just thought I'd share. How about this? Is that a function? No. Amazon is matching to both the movies, videos item in the range as well as to shopping. In order to be a function, every item in the domain must match to exactly one item in the range. Let's make it more mathy. I have the coordinate 1, 5, the coordinate 3, 7, and the coordinate 1, 7. Is this a function? Well, first of all, what is the domain? The domain is the set of first items, just like before. 1, 3, and 1. Of course, we only write the 1 and the 3 one time. The range then is the list of second items, the 5, the 7, and the 7. When you look at this, does this meet the definition or criteria to be a function? No, it does not, because 1 is not allowed to match to two different things. In a function, 1 can only match to one thing, 3 can only match to one thing. So over here, as soon as 1 matches to the 5 and the 7, I know it's not a function. How about that? Can you give the domain and the range and tell me if it's a function or not? Hopefully you paused the video and tried that. By the way, we call this relation H. We like to name these, but mathematicians aren't great at naming things. It's not real interesting, so we just call it H. You can call it Bill or Tom or whatever if you want. The domain is 2, 4, and 6. The range is the 0. Is it a function? Of course it is. 4 only matches to 0, 6 only matches to 0, 2 only matches to 0. This is like the Plants vs. Zombie example, in that they all match to the same thing, but there's no rule that says they're not allowed to do that. Here's what I'm going to do. I have a set of relations for you. They're listed in several different ways. I'd suggest pausing the video, taking a moment and trying these on your own, and then restarting the video to see if you are correct. I'm going to just assume you've done that, and I'm just going to put the solutions up here very quickly. A is a function because every item in the domain matches to one item in the range. B is not because if you look carefully, 4 is matched to 0. 4 is also matched to 3. That is unacceptable. This is not a function. C is not a function because 2 matches to two things, 1 matches to two things, and 0 matches to two things. Definitely not allowed. And D is in fact a function. -1 only goes to 4, 3 only goes to 15, 11 only goes to 15. Here's another opportunity. Once you give those a try, then restart the video. I'm going to assume you have already done that as well. I'm not going to read all the solutions to you this time. I'm just going to move on. Let's do this. We're at about 20 minutes now. Let's go ahead and call it quits at this point. This is the end of part A of our video. I am going to go ahead and make a part B here in just a moment as well. Make sure you watch both of those because there's a lot of information at the end of the other as well. If this has been helpful to you, make sure that you like and subscribe. Leave me a comment in the comment section. Make sure you turn on your notifications so that when we update our videos, you will get an announcement of that as well. Also, we do try and put some of our notes up on the Teachers Pay Teachers website if you're trying to get those, if you're a student who'd like to follow along as we're doing these. That's a great idea. If you're a teacher that wants to use this slideshow in your class, I also have that available on Teachers Pay Teachers as well. So thank you very much for listening. Make sure you check out the second part of this video. Have a great day. Take care.